So this time we would like to graph other trigonometric functions, and the winner this time is y equal to tangent theta. Y equal to tan t. So in here, and again, I'm kind of open to plotting again, and for plotting I have to have the reference table. Reference table is in the pink over here. Using the reference table, I calculate tangent of t. Tangent of t for t equal to 0 is 0 over 1. For t equal to pi 6 is 1/2 divided by square root of 3 over 2, which is the denominator simplified, becomes 1 over square root of 3. If you want to simplify this or rationalize this, it's square root of 3 over 3. For pi 6, sine divided by cosine is equal to 1. For pi third, sine divided by cosine is equal to the denominator 2 simplifies, becomes square root of 3. For pi half, it's 1 over 0. Oh, that's not possible. It does not exist. Now, I can use the newly made reference table for tan to calculate the values for other quadrants. Something to notice is that tan in the first quadrant, both sine and cosine are positive, so tan is positive. In the second quadrant, cosine is negative, sine is positive, so the tan is going to be negative. In the third quadrant, both sine and cosine are negative, therefore positive. In the fourth quadrant, sine is negative, cosine is positive, so the value is negative. So when you're using the reference table, just use the signs, the SIGN, plus minus, rather than what we used to use before, which was depending on sine or cosine. So now, 2 pi third, I know these are the values in the second quadrant. They all have to be negative. I put in the negative sign, and then I calculate the values. And so 2 pi third, 3 is over here. It should be negative square root of 3. Pi fourth, I get a negative 1. For pi sixth, I get negative square root of 3 over 3. For 0, I get 0, so the negative doesn't matter. Okay. Let's do this for the this one should be the third quadrant, and third quadrant what we have is 7 pi sixth. And then we have 5 pi fourth. Then we have 4 pi third. And 3 pi half. Okay, so 7 pi 6. And in third quadrant, everything is positive. 6 over here give me square root of 3 over 3. Pi fourth over here gives me 1. Third gives me square root of 3. And 3 pi fourth gives me, over here, sine is equal to 1, cosine is equal to 0, and that does not exist again. How about in the fourth quadrant? And I did this a little differently. I changed the positive notation to a negative notation over here. And so negative pi sixth goes back to the negative, to the denominator 6, and I should get a negative square root of 3 over 3 because negative sign over here. Negative 1. This one is negative square root of 3, and this one at negative pi half does not exist again. Okay. So let's try to put these values over here. Let's see. I know that at t equal to 0, at t equal to pi half, tangent doesn't exist. I also know at t equal to 3 pi half or negative pi half, they're the same thing, the same place in the in the unit circle, but at neither of those places the tangent exists. So I can go to negative pi half and pi half, and then add 3 pi half, and make sure that I know that the tangent does not exist in any of those. So this one is y equal to negative pi half, y equal to pi half, pi half. So I can find all these equivalent places either over here, where for all those t's that tangent I'm sorry, this should be t equal to. At t equal to, the tangent doesn't exist. Those are the vertical asymptotes. And now I can plot a few points and stay away from those lines. By the way, how many times do I go over here? Infinitely many times. And it seems like after every pi times for tangent of t, we repeat it. So there are, if you add pi to any of these or subtract pi from any of these, you end up with other vertical asymptotes, and infinitely many of them, in fact. Now let's try to graph at least one period for tangent, and we know the period for tangent is pi. So what is going to happen? At t equal to 0, tangent is 0. At pi sixth, tangent is square root of 3 over 3, which is 1.7 divided by 3. It's 0.56 or somewhere close that. There we go. And then at pi fourth, it's 1. And it's 1. And then at pi third, it's going to be 1.7, rounding it to 1.7-ish, and over here. And then back again in here, negative, negative, and negative. And it sort of goes it goes like this. And then it repeats itself over here, going through, and it repeats itself over here also, and very symmetrically, unlike what I'm drawing. And so that's the point, and then at every pi period, it starts repeating itself. So the next part is to the same principle applies, and we want to draw at least as y equal to secant of t, and then transformation on all of these will apply also.